With this one, and I'm kind of hoping that we will finish off these two pages, two examples. We're still on applications of linear functions. So applications. What have we done so far? We talked about how do we apply linear functions when you're given the equation. This is what we've done so far. These are the following scenarios. What we've seen so far is where we had that's ours too. Okay. So in terms of linear function, what we've seen is that we are given the linear equations. Okay, so some examples that we've done, we were given the equation itself, right? Then the one that we did yesterday, we are given the table of values. And because we don't have the equation, the very first thing that we had to do is to determine the linear equation. Okay, so that's what we did. The third thing that we're going to do today is that what if you're given just some kind of a description or some kind of a pattern. Okay, so what will happen? Let's see this one. So example number 5. The student council is planning to hold a fundraising dinner. Okay. They will profit $8 per dinner ticket, and the other costs for the dinner are for the hall rental and the music, which has a total of $300. Fill in the table for this situation. So in this particular case, your X is the number of tickets sold and the Y is the profit. Now, somebody asked me this morning, how do we know which one's X and which one's Y? Okay, and when we take a look at this, we are comparing tickets sold and profit. So the very first thing is this. We know that the total profit will depend on the tickets sold, right? Like the amount of money they are making depends on the tickets sold. So this is the dependent variable. Okay, so the profit will be determined based on the ticket. So this is the independent. So the independent will be our X, the dependent would be Y. Now let's fill this out. Okay. Now let's put in the context in here. So somebody's putting up a party. Well, for the party, they need a hall rental and the music. So right off the bat, they've already spent that money, right? So they're in a negative value. So they lost money, right? Now, the more money, the more tickets they sell, some of that money will go towards paying that off. And then later on, when they sold so many tickets, then they will start to create profit. means they're gonna earn money. So over here, what if they sold 15 tickets? Okay.
15 times 8 dollars.
Okay. So it would be 15 times 8, right? So 15 is 120.
So then do you do negative 300 plus 120?
Yes, that's right. Oh, let's clear everything off. I can clear everything off. Second function trace. 7, 1, 2. So I can go 15 times 8. Oops, 15 times 8. That's going to give me $120 worth of the tickets. But then we have to subtract what we paid for the hall and the rental music. So minus 300. So in this particular case, our total profit, we're still in a negative value. Is that okay? Does that make sense to us?
Yeah, it doesn't make sense because how 0 is negative.
Oh, how is 0?
Yeah.
So what they did is that they had to pay for the rental of the hall and the people who does the music. So the money already went out. They're paying that amount. So these two together is $300. Because the money, when we paid them, the rental and the music, that's minus 300. You're taking that away from your profit, how much money they made. Okay, let's go first. Okay. Now, what if we sell 25 tickets? What if we sell 25 tickets? So that's gonna be 25 times $8 per ticket. So now $200. So we made $200. But remember, we have to pay for the hall and we have to pay for the music. So we have to subtract 300. We got to pay for that. So we're still at negative 100. Negative 100. Okay? That's not enough. What if we sell 50 tickets? What would it be? So if we sell 50 tickets for $8 each, that's including the profit for the dinner, that's going to give us $400, right? That's the amount of money we get. But remember, we have to pay for rental of the hall and music, so we got to take away this amount. So now it's 100.
So for 15, we didn't pay for the hall or for the music?
Yeah, we still have to pay for that, so that's why it's being subtracted.
For the 15 now, 15 tickets.
Mm-hmm.
We didn't pay for the work and the music?
Are you doing this all every time?
No, not every time.
20,
Yeah.
That's what I'm confused on too, because start at negative 300, and then I go from negative 180 to 20 because the 200, and then you do negative 180 plus the 200 because that is the plus, so then you're down to 20. And then like it would be 420, and then next after that would be 1220. Because I don't know, it's confusing me.
Okay, I see. Okay. Yeah, we're only actually subtracting 300 once, right, for each category. Okay, let's see this. Nicole, can I ask a favor? Can I ask for you to close the door, please? Thank you. Let's start with this one here. So $8 per ticket. So 8 times 15. 8 times 15. So by the ticket sale, we have $120 that we made, right? okay, even if we sold 15 tickets, we still have to pay for the DJ and the rental of the hall. So minus 300. So that's gonna give us a 180. So here, this is gonna be a constant expense. We're subtracting. The only thing that's changing is this one here. Well, what if we sold 25 tickets? So 25 tickets times 15, okay? 25 tickets times 15. That's going to give us 370. Oops, sorry. 25. 8 times 25. So 8 times 25. So based on that, we've made $400 from ticket sales. Okay, minus a 300. So that's $100. Okay. So we're only really subtracting 300 once, but these ones are the different category, because this one here tells us how many ticket sales that we have. Is that okay? And then we keep going on with that. So $8 each ticket times 50. If we sell 50 tickets, okay. So that's going to give us 400. 8 times 8 times this one should be 200 minus. If we sell this one, it's going to give us $400 minus the 300 DJ in the hall. So we're earning 100. So the pattern here is that the more tickets we sell, the bigger the profit is. The more ticket we sell, the bigger the profit is. So the last category, what if we sell 100 tickets? So $8 a ticket times 100. That's going to give us $800. But then we pay for the $300. So it's going to be 500. So 500. What do we have so far? In this category, in this situation, we've generated a table of values. What's missing in here is the regression equation. So this is going to be on L1 and L2. Okay. Before we just jump onto that one, which is the next part, what we're going to do is we're going to graph it, okay? And we want to make sure that we're graphing it properly. On the x-axis talks about the number of tickets sold. Okay, so how many tickets sold do we have? It says from here from 0, 15, 25, 50. We're going to go from 0 to 100. 0 to 100. What do you think is the best scale that we can use for this situation? We go by 10? Is that what you said?
25.
We could go by 10. Yeah, there's nothing wrong with 10, right? That's okay. Yeah. We could go by 25. That's okay too. Right? The only thing that we're trying to do is that basically figure out the increments in between. We can go by 20 if we want. Okay? So let's go by 20?
Yeah.
Okay, let's go by 20. So 10 is, you're saying there's going to be a lot of tick marks right there. Let's go by 20. So 20, 40, 60, 80, 100. So 20, 40, 60. Our increments in here are equal. We're going up by 20. we've labeled the axes. That's important, and I'm trying to emphasize this. It's important to label the axes. On the y-axis, it talks about the profit, and I see there's a negative in here. So that tells us we need to go to the negative on the y as well. Extend it down below. Okay, so we're gonna go from negative 300 to 500. What do you think is a good scale? Hundreds, yeah? Okay, so that's good. So we're gonna go up by 100, so starting at 0, so that's gonna be 100, 200, 300, 400, 500, and then below as well, so negative 100, negative 200, negative 300. Okay, so we have a proper scale, and we have to label that axis. What do we put in there? This y is the total profit. I'll just put it on the top, and it's in dollars. Okay, that's good. So our graph is set up. Now we can start plotting those points. So 0, negative 300. So 0, negative 300. So that's this point there. 15. Okay, where's 15 in here? Be before the 20. It's gonna be negative 180. So that would be between the 200 or close to negative 200. Is that okay? This part here. This is 15, and then go down negative 180. The next one is 25. So where's 25 in here? Little bit over 20, and then we're gonna go to negative 100. Okay, 50. Where's the 50? It's gonna be between 40 and 60. And that is now in a positive amount, positive 100. And then last but not the least, 100 tickets is $500.
Looks like it's linear.
It kind of looks like it's a linear, right? Are we convinced that this is linear? Yeah. It's going to be linear because when you look at this, the more money, the more sales, ticket sales we do, the more profit it will have. And it's not gonna go up and then fall down again, right? That's not what's gonna happen. Now we're gonna go from here to that one. So far so good? Is that okay? That's not bad, right? Now if this is a test, will you be able to do that? I think you can. Okay, is this one should be B. Is this a linear relation? Yes. If so, sketch the linear regression equation on the grid above. Okay, we did that. And we have to write the regression equation. Yeah, okay. Now, how do we do linear regression again? Okay, if you were not here yesterday, we'll have to review that. So what we need to do is we need to enter these values on L1 and L2. So how do we do that? We go to Stat. Oops, turn it on first. Go to Stat. And then 1 for edit. Good. Right. And let's start putting these in. Go ahead. Okay, so we enter data on L1 and L2. What we need to do is we need to change the window. Change window. So we're gonna press window. What do you think are X min, X max, Y min, Y max should be? What do you think are X min? 0, right? Because our X is the number of tickets, so 0. What's the maximum?
120.
Okay, so you could go 100, you can go a little bit more, 120, that's okay. So I'll just put 120, so there's a little bit of extra room on the side. Now we go to the y-axis. What do you think is the y min? Yeah, we can go negative 300. Okay. What would be the y max?
520.
Yeah, you can go 500
Or 600.
or 600, right? Because remember, we're going up by 100, so that's okay. Yeah. I mean, this is just a start. Okay, this is just a start so that we can see our points, we can see our graph, but we could adjust, always adjust it later. Okay, good. So let's change our window. Okay, so X min is 0. So go to window, X min is 0. Go to X max, it's 120. Okay, don't worry about the scale. Y min is negative 300. Y max is 500. Oh yeah, you could put 520 if you. Okay. So what did we do so far? We've entered the data. We've changed the window so we can see them. And then the next thing that we gotta do is we need to turn on our stat plot. Okay. So turn on our stat plot. Do you remember how to turn on our stat plot? You're gonna go second y equals. Okay. Second y equals. And then turn on, we're gonna turn on our stat plot. Right now it's off, right? So press 1. Press 1, and then we're gonna choose on. Press enter. Okay, so again, we've entered the data, we've changed the window, we turn on the stat plot, so everything should be there. So let's check. Press graph. It should be very similar to what you have, right? Because pretty much the same window as what we did. No? Wasn't?
I'm having a problem.
Oh, okay.
Mine looks like yours, but there's like a line, there's like
Oh, okay. A line where?
like
Mine
going
is-
up across.
Mine's
going down.
Oh.
Hers is going, yeah.
Oh, maybe you didn't reset it.
You mean this one?
Maybe,
No,
It's
it's a
like
little
that.
different.
yeah.
Mine's going down.
Because I resetted mine, just so that nothing is there, like my old problems are gone. Yeah, yeah, your old problem is there. Yeah, whatever you have problem there. Yeah. Maybe you were working on something.
Must have been.
Yeah.
I got it
It's
down.
your old
I
problem.
figured it.
Yeah.
You too? And
Yeah, yeah.
what is the problem?
Get rid of that. Get rid of your old problems. Yeah. Because it looks like you didn't reset it, right?
Reset?
Can't do that.
No.
Yeah, it seems like, I like resetting things because it kind of sets it back to what it was. So is everyone pretty much the same, in the same place? Okay, good. Okay, you should write that on your thing. Reset my. And that's not cheating. I would allow that. Reset. Okay, good. The next thing we're gonna do is figure out the linear regression. So how do we do that? Go stat, stat. And then what we're gonna do is we're gonna go to calc. Go to calc. Okay, where's calc? You take the arrow to the right, right arrow, calc. And then we're gonna go to for linear regression. You're gonna go to for linear regression. Okay, so I pressed 4 already. So stat, and then you're gonna pick calc. Okay, it means arrow key to the right. And then we're gonna press number 4, button number 4 for linear regression. Okay, so what we need to do is we need to go over here. It says store regression equation. We wanna store our equation in, oops. Okay, store reg equation. So go down to that one. And then we're gonna go to vars. You're gonna press the vars button. And then you're gonna go to yvars. Okay. Notice the yvars. How do you get to the yvars? You go to the right. And then from there you're gonna press enter 4 times. Okay, so enter once, enter at y1, and enter it again, and then enter again. So basically enter 4 times. Okay, is everybody on this place now?
Yes.
Yeah, everybody? I meant everybody? Yeah? Okay, good. So this is the equation, y equals to ax plus b. We are going to substitute the 8 where you find the a. We're going to substitute the negative 300 where we find the b. Okay, so it's going to be like this: y equals 8x minus 300. That's our regression equation. Make sure we substitute the values into the equation. So the 8x minus 300. What does the x represent? Okay, x are the number of tickets, right? What does the y represent? The profit. The profit. Okay, good. So the next one. Next question. How many tickets do they have to sell in order to break even? That means to have a 0 profit. How many tickets do they have to sell until they break even? It means 0 profit. This is basically the point where they're going to start to break even, the profit. So it's going to be close to about 40 tickets, right? Is it 50? Oh no, 50, that's already 100. Yeah, so they made a profit of 100. They want to have to break even, so that means 0 profit. So we're going to try to figure that out. That's, what do you call that? That particular point there. That one is called the x-intercept. So in this case, they don't use x-intercept, but that's the x-intercept that we need. So we need to calculate the x-intercept. How do we do that? Okay, so press y equals. You'll notice that your first equation is there, okay? Yours is not? Oh, okay.
Can I just type it in?
You could type it in, yeah.
Because everything else is.
Everything is good, okay. And then we're gonna put y2 equals to 0. Okay. So that's your line right there, and then the other line should be right on the x-axis. 0. Y equals to 0. So we're gonna look for the intersection between the line and then the other line that says y2 equals to 0. So how do we do that? No, the window is already good. So we're gonna go to second function calc. Second calc. And then we're gonna go to intersect. Okay, 5 for intersect. So you're gonna go y2 equals to 0, and then you're gonna go second function trace, and then you're gonna go to 5 for intersect. And it's gonna ask us a whole bunch of questions. It's gonna ask you, is this your first curve? This is your first line? Yeah. So press enter. And then it's gonna ask you another question. Is this your second line or second curve? Y2 equals to 0? Yes. You press enter. And then they're saying guess again. Just press enter. Okay. Now we have our answer. It says here 37.5 tickets. Huh. Interesting. Now, even though it says 37.5 tickets, we have to ask ourselves, is it possible for us to sell 37.5 tickets? Right? So oh, okay. Oh yeah, I guess they didn't say that, but this is a student council, so I'm guessing there's no seniors there. No, that's a different way of thinking. Yeah, that's true. Okay. In this particular case, we would have to round off our answer to 38 tickets. So we need to round off to 38 tickets. Right? So when we sell about 38 tickets, we're very close to the break-even point. That means we didn't make a lot of money. We didn't make money, but we've just made so that we can pay off the rental and the music. Okay? What's the next? Is everybody clear on that one? Yeah? Okay. Let's take a look at letter E. What is the profit if there's 180 tickets sold? So what are we gonna do? They're telling us there's 180 tickets sold. They're giving us 100 tickets sold. So X is 180.
So would you just substitute X and substitute 180?
Yeah, absolutely. In this particular case, one way of doing it is by algebra. We talked about that yesterday.
Yeah.
You can do it algebraically. Yeah, let's do algebra. It's pretty easy. So y is equals to 8 times 180 minus 300. So y is equal to, okay, I gotta get out of here. Let's quit. 8 times 180 minus 300. Oh, they're gonna make $1,140. Okay. So that means if they sell 180 tickets, X is 180, then the Y is 1140. Is that one okay? Pretty clear? Okay. The very last one. It says if their goal is to make $1,000, how many tickets do they have to sell? Okay. Now, what they're giving us here is the Y value. Here they're given Y is $1,000. They're giving Y value is $1,000. What we need to do is figure out the X. So how can we do that? We can do algebra. We know how to do it. Okay. So how can we do that? So Y equals to 8x minus 300. So Y is 1,000. So I'm going to put 1,000 in here. 8x minus 300. So what we need to do, this is actually way back in our first few lessons, first few booklets, solving for x. Okay, so how do we do that? Add 300 on each side to cancel that. So we're left with 1,300 equals to 8x. And now how do we get the x alone? Was divided by 8, right? Divided by 8. So x, so 1,300 divided by 8. So it's going to be 163. 162.5, but like I said, we can't really give half a disc, yeah. Or half a ticket and then they get half the food. That's a possibility too. So it would be round off to 163 tickets. Okay. How does that, is that okay? Is that good? How does that feel? Is that okay? Yeah, we take it slowly, and it makes sense. Yeah, I know, it's a long. No. Oh, how do you do this with a calculator? How do you do this without calculator? Okay, here's what we're gonna do. Okay, what we're gonna do is y2 is equals to 1,000. Okay, y2 is equals to 1,000. Okay, now what we're trying to figure out is we can't even see that 1,000 mark, right? Because 1,000 our y max here was 500. So what we need to do is increase it up so that we can see the point of intersection there. So change.
We only change y max.
Yeah, we only change the y max. Right?
1,200.
Yeah, we can change it to 1,200. Okay, let's see. Let's change it to y max first. Okay. Okay, we'll see. Okay. In this particular point, we can't see their point of intersection, right? So what do you think we need to change so that we can eventually find the point of intersection? X max as well, right? Okay, so let's go change X max. So right now our X is 120. What should we change it to? We can change it to 200. Let's see if that's enough. Should be. There you go. So we see the point of intersection right there. Okay. Now we see the point of intersection. What do? We go second function, trace, Second function, trace. And then we're gonna press 5 for intersect. They're gonna ask us, is this your first curve? Yes, press enter. Is this your second curve? Yes, press enter. And then press enter again. And then you'll notice that we got the same answer, 162.5. Okay. So that's the other alternative. Or, I'll just write it down in here. You go y2 equals to 1,000. And then you're going to go second function, trace. Second function, trace. And then we're going to press 5 for intersect. Yeah. The thing about that is that we should be able to see their point of intersection. Is that okay?
Y2 or Y3?
Y2. Y2. Yeah.
It's simple.
Yeah.
Y2 or 0?
Yeah, you can just change it to 1,000. Okay. I'm gonna go over. Okay. Okay. See ya. Let's go over example 6. I just really want to finish this. Okay. There's 8 centimeters of snow on the ground, and it's melting at the rate of 0.5 centimeters per hour. Okay. Now, there's no information. So it says here there's 8 centimeters on the ground, and it's melting at the rate of 5 centimeters per hour. Complete the table shown below. So we go 0. So this is 0.5 centimeters per every hour. So we can go 0, 1, 2, 3, 4. Okay. So at 0 hours, how many centimeters of snow is there on the ground? Is 8. Okay. Now, it's melting at the rate of 0.5 centimeters per hour. So in 1 hour, how many centimeters of snow are there? 7.5. What's the next one? 7.
6.5.
6. Very good. Okay. Now what we're going to do is we're going to use this data, the graph on here. So the time is X, amount of snow is Y. Yeah. Okay. So the time is measured in hours. So how do we go by with this one here? What do we do? What should we go up? We need to go up from 0 to 4. Okay, 0 to 4. And what's our increments? What should we do? By 1. Okay, so we can go 1, 2, 3, 4. Okay, that's good. Now, what about this one here? On the y-axis, we're going to go up by 1s. Okay, so starting at 0, and what do we go up by? How high up do we need to go?
Go by 1.
We can go up by 1, and then up to 8, right? Yeah. So 1, 2, 3, 4. Good. And then this one here is the amount of snow. And it's measured in centimeters. Okay. So let's go ahead and graph that thing. So 0, 8. That's that point there. On a 1 hour, it's 7.5, so it's going to be right there. 2 hours is 7. 3 hours is 6.5. 4 hours is 6. Okay. Now, is this linear? Yes, it's linear. And we're gonna find out the regression equation for that one. We're gonna do it a little bit faster this time, okay? Because I know everyone wants to go to their next class. Let's clear off everything first, okay? So that our old problem is gone. Clear out your old problem. Second function plus 7, 1, 2. Okay? Everything is gone. Now we're gonna type L1 and L2 values. Okay? So let's do that. Okay. Okay, so we typed in our L1, L2 values, and we're gonna change our window from 0 to 4 on our X. So 0 to 4. And on our Y, we're gonna go from 0 to 8. Y min is 0 to 8. And we're gonna turn on our stat plot. And if second Y equals second Y equals, okay? Let's do the regression equation together. So regression equation, we go stat, calc, it's linear regression, so we're gonna press 4. We're gonna store this in Y1, okay? So go to store regression. You okay? So regression equation. Oh, you didn't do the old problem. Did you clear the old problem?
Yeah.
No, you didn't. You
I
didn't.
didn't,
Okay.
yeah.
Yeah, clear it up. Yeah. Okay. How do you store? Vars. Go to Y vars. Enter, 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 enter. So our regression equation should be Y equals to negative 0.5 x plus 8. So negative. That one should make sense, right? Because our line is going down. That means our slope is negative. Right? So far, so good? Huh? Yeah. Mismatch. Oh, because you have an L1 there. Go stat, calc, 4. And then you go here. You go vars, Y vars, enter, enter, enter. Oh, dimension mismatch.
Can you check L1? Can you start?
Oh, there's one here. You missed a number. You forgot a 0.
Oh, zero.
Yeah, that's fine. Okay.
Yeah.
Okay. It's okay. You just follow along with this one for now. Okay. The next is everybody okay? If you want, just follow along. Just write it down. Okay. Without doing that on your calculator, because you know that. already. It just takes time. The next question is, how long will it take for the snow to melt? How long will it take? They're asking for the time for it to melt. Now, this one here, it doesn't tell you specifically, but they're asking for the x-intercept, right? Because we want everything to be melted. So this one here is calculating the x-intercept. So how do we calculate the x-intercept?
Second trace, 5 intercept.
Now this one, we don't even see the x-intercept in there. So what we need to do is we need to change the window. Let's just change it to 20. 'Cause we could always change it later on. Okay, there you go. Now we can see the x-intercept. So y2 is 0. So you have 2 lines going there. X max. So, yeah. Just listen to this one for now, and just write it down. Yeah. So x, we change the x max to 20 so we can see where it's gonna go, right? So here, when we press it, change the x max to 20, we can see the x-intercept right there. How do we do that? So y2 is equal to 0. Go second function, trace. Go intersect. They're going to ask you, is this your first curve? Yes. Is this your second curve? The y2? Yes. And then guess. Enter.
X is 16.
X is going to be 16. So it's going to be 16. X-intercept is 16. 16 what? Hours. Because hours is on the X. The next question. When will the snow melt to a depth of 3.75 centimeters? So when will the snow melt to 3.5 centimeters? Okay. What did they give us in here? Centimeters. They're given the y value. The y value is 3.75. So they're giving us the y value. So let's go to that. Y equals y2 is 3.75. Okay, and if we press graph, you're gonna see another line. This is your y1, and your y2 would be that one. That point of intersection would be the one that we need. Second function, trace. 5 for intersect. Enter, enter, and enter. So it's giving us x is equals to 8.5, y is equals to 3.75. The question is, when will the snow melt to a depth of 3.75? So which one is that? 8.5 hours. So 8.5 hours. And then lastly, what are we assuming regarding our answers in part C and D? Huh? Yeah, we are assuming that, okay, we're assuming that the snow melts at the same rate, right? We're assuming that the snow melts at the same rate, okay, how fast it melts. And we're also assuming that there's no more snow, or we could assume that No more snow falling. Falling on the ground. Okay. How's that one? Is it getting better?
This one is simple. The last one is simple. This one, yeah, is easy.
This one is easier?
Yeah.
Yeah, it might be easier because we've taken our time to really talk about it. Right? Now it's just a matter of writing things down using your calculator.